Well, welcome back to another topic in our sequences and series chapter. Last night we focused on adding, and we call that arithmetic sequences. Tonight we're going to focus on multiplying, and that's called geometric sequences. The terms of a geometric sequence have what we call a common ratio. Ratio means we are looking for a number to multiply by. Recall from last night, arithmetic sequences had something called a common difference. So we do want to make sure that we understand there is a difference between the two. A ratio is used in geometric, where the common difference, or adding or subtracting, is used in arithmetic. So question A, determine the next three terms of the sequence. 3, 3/2, 3/4, 3/8. Identify the common ratio. So by them saying identify the common ratio, they're implying you should be looking for something to multiply by, and that's the key. So I'm not looking for something to add by or divide by, that's out. I'm just looking for multiplying. So I'm saying to myself, 3 times what is going to get me 3/2? Or 3/2 times what is going to get me 3/4? And common meaning they have to be the exact same thing. Well, a lot of people, they jump to dividing right off the bat, which is okay, but we have to make sure our answer is actually something we're multiplying by. A lot of people like to say, well, 3 divided by 2 is 3/2. So instead of saying divide in your head, we want to say multiply by the reciprocal. So maybe make a note for yourself. If you're thinking division, okay, and I'm not going to write it all out, but you should. If you're thinking division, multiply by the reciprocal. So dividing by 2 is the same as multiplying by 1/2. And let's see if that works. On the top I get 3, on the bottom I get 2, and that's what I wanted. Now does that ratio of multiplying by 1/2 work for the next term? Well, on the top I get 3, that's what I want. On the bottom I get 4, that's what I want. So I think I've got it. Let's test it in the next step. If I multiply by 1/2, I get 3, and then I get 8. So it looks like it works. So I'm going to say my common ratio is times 1/2. And if I keep multiplying times 1/2, I should get 3, what would my next term be? 16ths. And then 3 32nds. And then 3 64ths. B, given the first term in the common ratio, find the next 4 terms. Okay, so again, the key is that they're telling me it's a ratio, so I'm saying I know I need to multiply. Well, if the first term is 3 and I'm multiplying by 2, this should be easy enough. We're just going to multiply by 2. So I would get 6, multiply that by 2 is 12, 24. We need 4 terms, that's 1, 2, 3, and 48. And that's simple, if I know the first term and the ratio. I'm going to give you a second to try number 2. So we know the first term is -2, and you're going to multiply by 2/3. So pause it, give it a try, and then we'll compare. So I've got my answer in purple, hopefully it matched yours, and in black I just wrote down what I was doing. So I said times 2/3, so 2 times -2 is -4, there's technically a 1 there, times 3 is 3. Multiply times 2/3 gets me -8, 9. Multiply by 2 and 3, -16, 27, and again, to get my last one there. Okay, so let's carefully get this written out. Recall, we had an explicit rule for arithmetic. Our rule was a sub n equals a sub 1 plus n minus 1 times d. And we said what's nice is that they're going to give you the explicit on the exam. What's not nice is they think you need to memorize the recursive. So let's remind ourselves, in recursive you need to know the first term, and then recursive means start with the previous term, which is a sub n minus 1. And because it's arithmetic, arithmetic means to add, and you add the common difference. Now, just like we had rules for arithmetic, there's rules for geometric. So again, they're going to give you the explicit on the exam for geometric. So we're going to write it down. A sub n equals. Now it's going to start very similar. It's going to start with a sub 1 just like the other one did. But now I think it's just common sense. If arithmetic meant to add and we used a plus sign, geometric means to multiply. So we use a times sign. And what are we adding? We're adding the ratio, and that's raised to the n minus 1. Now again, recursive, they're not going to give you, so you do have to memorize. You're always going to say, I need the first term. And then I'm going to start with the previous term, a sub n minus 1. And again, just common sense, geometric means to multiply by the ratio. All right, example C. If a sub 10 equals 8 and the ratio is 2, find the first 5 terms of the sequence. So notice it says nothing about the previous term. So this has nothing to do with recursive. So let's start with our explicit formula. A sub n equals a sub 1. It has a ratio, so I know it's times the ratio raised to the n minus 1. Now the only thing I can plug in, obviously, is the 2 for the ratio, and I can plug this term in. So I'm going to say a sub 10, so that's telling me all my n's are becoming the number 10, equals a sub 1 times 2 raised to the 10 minus 1. And I know a sub 10 is actually 8. So 8 equals a sub 1 times 2 to the 9th power. So I get 8 equals 2 to the 9th is 512 times a sub 1. And then obviously I'll divide that over to solve for a sub 1. A sub 1 equals 8 divided by 512. Now obviously you could write that as a fraction or a decimal. Clearly it's going to be a long decimal, so it's probably just easier to leave as a fraction. So now once I know the first term, I need the first 5. And let me start by rewriting this first term, 8 over 512. And my ratio is 2, so I'm just multiplying each of these by 2 over 1. So my next term would get me 16 over 512. My next term would be 32 over 512, 64 over 512, and 128 over 512. And that leaves me with the first 5 terms. All right, if a sub 1 equals 24 and a sub 5 equals 1.5, find the ratio and then find a sub 10. Okay, so let's start with our formula. Obviously, they're saying find the ratio, so we know it's geometric. So a sub n equals a sub 1. Geometric means times the ratio raised to the n minus 1. Okay, what do I know? I actually know a sub 1, so that's really nice. A sub n equals 24 times the ratio to the n minus 1. And now they're telling me a sub 5 is 1.5, so I'm going to replace all my little n's with a 5. 24 ratio. I'm going to do that in my head. 5 minus 1 is 4. And I can replace a sub 5 with 1.5. Now, I'm not a huge fan of decimals, so, well, I'm going to write it as a fraction. 1.5 is 3 over 2. If you didn't know that for some reason, you can hit 1.5 on your calculator and then math frac. Equals 24 to the r to the 4th. Okay. Now remember, when you solve any simple equation in algebra, and you've been doing this since the 8th grade, you have to isolate the variable first. So my goal is to get this piece alone. I can't just go and take the 4th root until I get this term alone. So I first have to divide both sides by 24. Now again, we don't really like to divide fractions, so instead of saying divide by 24, clearly your calculator can do all this, I'm going to multiply both sides by the reciprocal, 1 over 24. So I'm going to say I get, my pen here, 3 over 48 is equal to r to the 4th. Then I'm simply going to say to get rid of a 4th power, I'm going to take the 4th root. And now I am going to use my calculator. I'm going to hit the math button, and if I scroll down, there's an any root. I believe it's number 5 on my calculator. And I'm going to take the 4th root of 3 over 48. And I get 0.5 or 1/2. And that tells me the common ratio is 1/2. Okay, so now I need to answer the question. First it said find the ratio, so check, we did that. Now it says find a sub 10. Well, let's plug in everybody we know. We know the formula is a sub 1, or a sub n equals a sub 1, so that's 24, times the common ratio, which we just said is 1/2, to the n minus 1. So now if I want to find a sub 10, again I'm going to replace all my little n's with the number 10. So 24 times 1/2, and if I put a 10 in this n, 10 minus 1 becomes 9. Now at this point, there's really only one thing you can possibly screw up. So A, you should be typing this in your calculator, and B, here's where we got to be smart. This exponent is only sitting on what number? I heard you. It's only sitting on the 1/2. You cannot, I repeat, you cannot multiply these two together and then raise it to the 9th. This 9th is only on the 1/2. Okay? So it's really 24 times 1/2 to the 9th power. Okay, which happens to be 1/512. But again, I mean, I'm typing this in the calculator exactly how I see it, but I just want to be clear that you don't multiply those together. So that number times 24 gets me 3/64. Okay. All right, in our next example, a sub 4 equals 64 and a sub 10 equals 262,144. Find r and find a sub 1. So again, this has nothing to do with the previous term, so I'm not going to use the recursive formula. I'm going to use that explicit formula. So I always start by jotting the formula down. A sub n equals first term times, because it's the ratio, to the n minus 1. Okay, now you'll notice I don't have the first term and I don't have the ratio. So all I can do is use these two pieces of information. I can say a sub 4 equals a sub 1 times the ratio, and again I'm going to do that 4 minus 1 in my head to get 3, and I know a sub 4 is actually 64. So 64 equals a sub 1 ratio cubed. Okay, and I'm going to box it in. I can't go any further. That's as far as I can go with that term. Now I'm going to use my other piece of information. I know a sub 10 is equal to a sub 1 times the ratio to the 10 minus 1, or to the 9th power. And I really know a sub 1 is 262,144. A sub 1 r to the 9th. And I'll box that in because it's as far as we can go. Now remember, we did this yesterday with arithmetic. You have to solve one of these equations for a variable and substitute it into the other one. So it truly doesn't matter which one you solve for. I'm going to solve the first equation, I guess, for a sub 1. And I'm picking that because it's the only thing that's actually the same in both equations. So that's why I'm picking a sub 1. So to get that by itself, I would just divide both sides by r cubed. So I can say a sub 1 is equal to 64 over r cubed. And I'm going to substitute this into a sub 1 here. So I'm going to get 262,144 equal, so I'm replacing this a sub 1 with 64 over r cubed times r to the 9th. Now notice how neat I'm writing it so that I can clearly see who's on the top and who's on the bottom. So now we're just going to use some exponent rules. If I have r to the 9th on top divided by r to the 3rd, when I divide, what do I do with those exponents? Well, hopefully you said it, you subtract those exponents. So I'm going to get 64 here times r to the 6th. And then my goal is to solve for r. So remember, just like in any algebra equation, you want to isolate that. So I'm going to divide both sides by 64. And I'm going to grab my calculator real quick to do that. And I've got 4096 equals r to the 6th. And then to get rid of a 6th power, I'm going to take the 6th root. So again, my calculator is going to do that for me. I'm going to hit that math button, arrow down to number 5, which is any root, and type that in, and I get a ratio of 4. Okay, so now there was two parts to this question. One of them was find the ratio, and the other is to find a sub 1. So I now know in my equation a sub n equals a sub 1. The ratio we just said is 4 raised to the n minus 1. I have to figure out that a sub 1. So again, I can use either one of these pieces that I know. It doesn't matter. I'm going to pick this one because it's slightly smaller and substitute that in. So a sub 4 equals a sub 1, 4. And if I plug in a 4 for my n, I get 4 cubed. So 64 equals a sub 1 times 64. Therefore, divide that out, all of that, and a sub 1, our first term, is actually just the number 1. Now, how can you check if you're right? Well, you know the fourth term is 64, so we could work it out real quick. If my first term is 1 and my ratio is 4, the next term would be 4, then 16. And if I multiply that, I should get 64, and there's my fourth term that matches. And if I were to keep going multiplying by 4, my 10th term better check out to be that. Letter F. If a sub n equals 4 times a sub n minus 1, and a sub 1 equals 8, write an explicit formula for a sub n. So here's where knowing these formulas comes in really handy. Because I see right off the bat this a sub n minus 1, I know this is recursive. And because I see times, I know it's the geometric recursive formula. So I always start by writing it out for myself. It's a sub n equals the previous term times the ratio. So basically they're telling you, if you match that up, a sub n minus 1 times, there's my ratio. I know that the ratio is 4. And then they were generous enough to give me a sub 1. So this question is actually very easy. Now I just need to write my explicit, which is a sub 1 times the ratio to the n minus 1. So a sub n equals a sub 1, which is 8, times my ratio of 4 to the n minus 1. And I just want to reiterate, you cannot not say this is 32 to the n minus 1. I want to be very clear, this exponent, we've already done exponent properties this year, is only on the 4. So this, in fact, is my final answer. All right, writing a recursive geometric formula. So I'm given a sub 1 and the ratio, write a recursive formula. So again, I have to be given a sub 1 when I do recursive. And I need to know it's a sub n minus 1 times the ratio. And again, this was super generous. I already know my ratio, so a sub n minus 1 times 3. So I need to state the first term and my recursive formula. Now, of course, it's not always going to be that straightforward. They don't have to give you a sub 1. So notice it says find a recursive formula. So I have to go figure out a sub 1. So I'm going to have to start with my explicit. A sub n equals a sub 1 times the ratio to the n minus 1. I know my ratio is 2. And if I plug in 15, a sub 15, I get a sub 1, and 15 minus 1 is 14. So I really have 16, 3, 8, 4 equals a sub 1. And 2 to the 14th, I'm getting 16, 3, 8, 4. So now I can go solve for a sub 1 by dividing that out. And I know that my a sub 1 is equal to 1. So now I can write my recursive formula. I know my first term, a sub 1 equals 1. And then my formula is a sub n minus 1 times the ratio, which is 2. All right, we've got one more big bear to tackle. So this one's even uglier because they don't give you the ratio or a sub 1. So you have a lot of finding to do before you can just go write a recursive formula. So we know a sub 7 and a sub 9. So I'll start with those explicits. A sub n equals a sub 1 ratio to the n minus 1, and I'll plug in my two pieces. So a sub 7 equals a sub 1 ratio, 7 minus 1 is 6. So 32 equals a sub 1 r to the 6th. And again, that's as far as I can go with that piece. And then I'll do the same with the next one. A sub 9 equals a sub 1 ratio raised to the 9 minus 1 is 8. So really 288 equals a sub 1 r to the 8th. And again, all I'm going to do is solve one of these equations. It doesn't matter which one for a sub 1. I'm just going to take the first one because it's in front of me. So I'm going to say a sub 1 is equal to 32 over r to the 6th. And I'm going to take that and substitute it carefully into this equation. So I've got 288 equals, and in place of that a sub 1, I'm putting 32 over r to the 6th times r to the 8th. I'm just going to clean that up nicely. So I've got 288 equals 32. And remember, when I divide, I subtract. So this is really r squared. So 288 divided by 32 gets me 9 equals r squared. Square root, therefore r equals 3. So right now I have my common ratio. Don't forget, I still need to get a sub 1. Now look how simple this is. Box this equation in here. It already says a sub 1 equals. So I really just need to plug my ratio in here to get a sub 1. So I have 32 over 3 to the 6th. And 3 to the 6th is 729. So I would say a sub 1 equals, not the prettiest number, but who cares, 32 over 729. All right, so we're ready to write our recursive formula. So remember, you're always going to start by saying a sub 1 equals 32 over 729. And then my rule is a sub n equals the previous term times the ratio to the n minus 1. And that's about as ugly as it can get for these geometrics. Well, we've got a lot of practice, and we'll get some more in class tomorrow. Have a great night.